Okay, so today we're going to talk about function notation. For our we will statement, we will evaluate functions expressed in function notation given one or more elements in their domains. So a function can be thought of as a machine that assigns one input to one output. And what does that look like? First, we've got to look at all of the different notations and to figure out what the information is telling us. So here, f, now remember, this can be any variable. The only variable you probably will not see here is y, but you can see just about any other variable here, and all that is telling you, it's telling you the specific name of your function rule. This is the function rule f. If this was a g, this function rule would be g. Okay? And when you read this, you say f of x. So whatever this variable is, you would replace it here. Whatever is in the parentheses would replace x. Okay, but it's not fx, it's not like the channel, it's f of x. So what is this little x inside the parentheses? What is that telling you? Well, that's telling you the input value. It's telling you what to plug in for all the variables in your function rule. So you can think about it like this. The input value is inside the parentheses and is plugged into the function rule. So notice the emphasis on all the ins. Input, inside parentheses, in the function rule. Now, when you look at this as a whole, f of x, that is simply another way to state your output value. It's your result from plugging in the input value into the function rule. So the most common output value variable that we use is y. So you may see or think of this as another way to say y equals and then your function rule. Okay? And then of course, I've said this several times, but 3 times the value of x plus 4, this whole side, is your function rule. It is the operations you will perform on the input value, but they have to be in PEMDAS order. And to get your output value from the function rule, you can use mental math, but you need to make sure it is correct, or you can use your calculator. But remember, we're going to learn how to do that on the back. So now let's look at some examples. How are we going to use this function notation to get our output value? So I have a visual here. Think of this as a machine. So this would make x squared plus 3 our function rule. And we are going to obviously plug in an input value, perform these operations in PEMDAS order, and then we're going to get an output. So it says find and illustrate f of 2 and f of negative 1 using the function machines below. So now I just have to figure out what is my input value. I have to know my input before I can get my output. And if you notice, I have numbers inside the parentheses. So those are my input values. So the first one I'm going to attempt to figure out is 2. Now, when you go to plug in your rule, what you want to do is you want to copy your function rule. But when you have a variable, you are going to replace the variable with empty parentheses. So my x is empty parentheses. I now have to put it to the power of 2 plus 3. Now I'm going to take care of plugging in my input here. And what are we going to input into the function rule? That would be 2. And so now I'm going to figure this out on my calculator. So 2 squared is the same as 2 times 2, which is 4. And what is 4 plus 3? 7. So my output for this function rule is 7. So when f of 2 is equal to 7, the output value is 7 when my input value is 2. And all of those English words are taken care of through this notation. You can also think of this as an input-output pair, and now I can write it as the ordered pair 2, 7. So I can go to the origin, go right 2 and up 7 and plot my ordered pair. And now I have 1 point that will show up on the graph line for this function rule. So let's try this again because we're practicing plugging in input values to determine and evaluate our output values. So again, I'm using the same function rule, and my new input value is -1. And I know it's -1 because it's inside the parentheses. So I'm going to plug in -1, and now I'm going to perform PEMDAS operations. So I'm going to recopy my rule, but instead of writing x, I'm going to write empty parentheses. Now I'm going to ask myself, what is my input value? What needs to be plugged into my rule? And that would be -1. And now I'm going to calculate what is -1 squared. So that would be like -1 times -1, which is 1. And 1 plus 3 is 4. So writing this in function notation, I can say f of -1 is equal to 4. The output is 4 when the input is -1. And just like before, we can write an ordered pair. So I have the ordered pair -1, comma, 4. But what will that look like if we do not have just a number for our input value? And that's what the next example has us doing. So here they're asking us if f of x is equal to the function rule of the difference of 2 times the value of x and 5, or 2x minus 5, which expression represents f of x plus 1? Well, the first thing we've got to be able to do is pick out our input value and our function rule. So remember, our input value is going to be inside the parentheses. So I have some parentheses here. So my input value is either going to be x, or it could be x plus 1, because those are the only terms inside of parentheses. Well, if you remember from the front of your notes that your function rule is always going to be after f of x or g of x, I can figure out that 2x minus 5, that is going to be my function rule. So I'm going to go ahead and highlight that. So I know when I find my input value, it is going to be plugged into this rule, 2x minus 5. But now we're going to go back. Which of these is going to be my input value? So let's look. If I chose x to be the input value and I plugged it into my function rule, is this function rule going to change? Hopefully you said no. That would be correct. It is not going to change. It is still going to be 2x minus 5. Well, do you think they're going to ask us to figure out the expression if they're not going to change the function rule from the original? You would be correct. So this tells me that x is just telling me, here's my function rule. This is not telling me my input. Actually, my input is the x plus 1. So this is my input value. And this is what is going to be plugged in to my function rule, 2x minus 5. So just like before, when our input values were numbers only, we are going to rewrite our function rule using empty parentheses. I am not changing my process so that I'm being consistent on how I calculate and determine these function values every time. So I'm going to say 2, I have an x minus 5. And now I'm going to ask myself, just like I did before, what is the value that is going into my function rule? And that value happens to be x plus 1. Sometimes your input value will not be just a number. So I'm going to ask myself, can I type this into my calculator? And you should say no, because remember when we were solving equations, you can only type x in your screen if you know its value. Have we been told the value of x? No, we have not. So we're going to have to solve this problem using good old-fashioned PEMDAS. And we are going to have to use our operations to work and perform as much math as we can. Here's another clue that I am not going to get an actual number answer. When it says which expression represents, this word expression is telling you that you are going to have a combination of numbers and variables. So my final answer is going to be a combination of numbers and variables. And if you check your multiple choice answers, you can see I do have terms with variables and I do have terms that are just numbers. I am not going to get a single number answer like we had on the first example. So now we're going to work through PEMDAS to work this down as much as we can before we can no longer perform any math operations. So I'm going to go through PEMDAS. Parentheses. I have parentheses, but I'm going to look inside and ask yourself, can you perform the operation of addition? No, because I still do not know the value of x. It's a question mark, and I cannot add 1 to a question mark and get an actual number. So we have no parentheses. There are no exponents. So now I'm going to go to the operation of multiplication, and I see that I have distribution. So yes, I can perform multiplication. So we are going to multiply x and the 1 in the parentheses. Those both get multiplied by 2. So 2 times x is 2x. 1 times 2 is positive 2. So the symbol for positive 2 means that I'm going to be adding. And then I'm just going to bring down my minus 5. So now I'm on to my next order of operations, and I'm at D for division. I do not see any division. And then when you get to addition or subtraction, you can kind of work these the same way, because now you have run into a situation where you are combining like terms. And I may need to use addition, or I may need to use subtraction to combine my like terms. So if you look at your problem and ask yourself, do I have any like terms? Hopefully you say yes. I have a positive 2 and I have a 5, and the subtraction sign tells me the 5 is negative. So when I combine these, I'm going to start with 2, and this means I'm taking away 5. And 2 take away 5 is a negative 3. But when I bring down my 2x and I read this together, it's going to say 2 times the value of x minus 3. Now, since these are not like terms, I have performed all the math operations I can, and this will be my final answer. I have worked the problem as far as I can, and hopefully see that the correct answer is A. Next, now we're going to look at how do I read and figure out function notation when they just give me a graph. I no longer have a rule, and now I'm reading it off a graph picture. So, it says in the graph above, which is really beside, it says f of 4 equals 1. So if you remember, your inputs come inside the parentheses. They are telling you here that x equals 4. Okay, so if I go to where x equals 4, I'm going to go up to my graph line, and then I'm going to go over to my output line to read my output value, and look what value it is, 1. So in this picture, or in this statement, f of 4 equals 1, they were telling me that I was at the ordered pair 1, 4. When I have an input value, 4, 1. When I am at an input value of 4, my output is 1, according to this graph picture. So that is all it is. You find your input value, you go up to your graph line, and then you go over to your output, your y-axis line, to see what number you are going to hit. So now let's see. Find the following values. F of 6. So they are telling you, because it is inside the parentheses, that your x value is 6. So I'm going to go to where x is 6. I'm going to go up to my graph line. And now to read my output value, I simply follow this grid line back to the y-axis, and I hit the number 2. So this is the ordered pair, 6, 2. Right? 6 up 2. Boom. F of 2. So now I'm going to go to 2 on my input line and go up to my graph line. And now I need my output value, so I'm going to go back to the y-axis, and I hit the number 4. So this is the ordered pair, 2, 4. F of 0. This is telling me my input value, my x value is 0. So that is right here at the origin, and I need to find my y value. So all I have to do is go straight up till it hits the y-axis. And what number on the y-axis does it hit? 7. That is where my graph line hits the y-axis. So f of 0 is equal to 7, which is telling me this is the ordered pair, 0, 7. Next, I have f of 5 equals. So they're telling me my input value is 5. So I'm going to go to my input line, which is my x-axis, my x values. So there's 5. I'm going to go up to my grid line. And now I'm going to follow back to my y-axis. Well, it doesn't exactly hit a whole number, but I look to be halfway between 1 and 2. So what is the output value that would be halfway between 1 and 2? And hopefully you said 1.5. So this is the ordered pair, 5, 1.5. So sometimes your output value will fall in between one of your grid lines, so it is your job to do your best at estimating what that value is. So now, if you can find your output value given an input value, can you go backwards? If they give you an output value, can you figure out your input value? This is what this question is asking me. For which values of x? That means my input value is a question mark. I don't know what my input value is, but I know that my output value is going to be 1. So here's what we're going to do. We are going to highlight when the input value is 1. And this grid line right here is when the output value is 1. So this means y equals 1. So now I'm going to follow this grid line at 1 until I hit my graph line. Boom, there it is. And now I'm going to go down to the x-axis and see what my input value is. And it's 4. So f of 4 is equal to 1. Let's see what other x value is equal to 1, because it could be more than 1. So I'm going to keep following this grid line at 1. This is when my output is 1, output is 1, output is 1, output is 1. Oh, there it is. And now I'm going to follow this back to the x-axis. Well, it hits between 9 and 10, but it's closer to 9 than it is 10. And it doesn't look like it's halfway. So it's less than halfway between 9 and 10. So I have to make sure that I pick an input value that is smaller than 9.5 but bigger than 9. So I'm going to pick 9.25 because that just seems like it's smaller than 9.5 but bigger than 9. So that for me seems like to be a reasonable estimation. Hopefully you now understand how to read input-output values using function notation from a table, and you know how to use your input value to calculate your output value when you plug it into a function rule. You are now going to move on to the next set of notes.